Guys, welcome back to TechDose, and in this video we will look at a number of ways to arrive at destination problem, which is from Leetcode number 1976. This is based on dynamic programming on graph, where we will be applying greedy as well as dynamic programming techniques. A prerequisite before watching this is to learn the dijkstra algorithm. If you are a beginner, then I will be sharing you the dijkstra algorithm implementation using array. And after that you have to solve this find minimum time to reach last room problem, which is a priority queue heap implementation. The part 1 and part 2, you can just solve part 1, which is from 3341 Leetcode number, and this is for intermediate people. But if you are already aware about dijkstra algorithm using the priority queue heap implementation, then you can solve this problem directly. Let's now look at the problem statement. You are in a city that consists of n intersections numbered from 0 to n-1 with bidirectional roads between some intersection. Bidirectional means undirected edges. The inputs are generated such that you can reach any intersection from any other intersection, and that there is at most one road between any two intersections. You are given an integer n and a 2D integer array roads, where road set I is ui vi time I, means that there is a road between intersections ui and vi that takes time I minutes to travel. You want to know in how many ways you can travel from intersection 0 to intersection n-1 in the shortest amount of time. So they are asking about reaching from a source to destination in the shortest amount of time, and the edge weights in the graph are actually the time it takes to reach from one node to the other node. So you can imagine that if you want to find out the shortest path or the shortest time, minimum time between any source and destination, then you are going to apply the dijkstra algorithm. Another algorithm you can think of is the Floyd-Warshall, but that is an all pair shortest path. It will be an overkill for this problem. So we just need to find out the shortest path between two nodes, the source and destination. You can go with the triple SP, which is the single source shortest path. We need to return the number of ways you can arrive at your destination in the shortest amount of time. Since the answer may be large, we need to return modulo 10 to the power 9 plus 7. Now if you look at the example given, then in this graph they are always assuming 0 to be the source node and n-1, which is the last labeled node, to be the destination node. Okay, so since your n value equals to 7, therefore the source is always going to be 0 and the destination is always going to be n-1, which will be 6. This is already fixed. Now, in how many ways can you reach from source to destination with minimum cost involved? So first, let's see what is the minimum cost. The minimum cost will be 7, 5 plus 2. You can just check it out, it will be 7. So in how many ways can you reach from 0 to 6 with cost 7? You can reach via 4. So 0, 4, 6 is one way. You can directly jump from 0 to 6 through a direct edge. So 0, 6 is another way. You can go from 0 to 1, 1 to 3, 3 to 5 and 5 to 6. This is another way. So this is the third way. And then you can go from 0 to 1, 1 to 2, 2 to 5 and 5 to 6. This is the fourth way. And there are only 4 ways with the minimum cost. If you consider 0, 1, 3, 6, this is having a higher cost, 2 plus 3, 5 plus 3, 8. But our minimum cost is 7. That is why it was not counted. Okay. So the challenging part of this problem is not dijkstra, but the challenging part is to count. Okay, fine. Now let's look at the constraint. In this case, the number of vertices given are 200 and the number of edges will be order of n square, which is n into n-1 by 2. So you can imagine that if you write a v plus e algorithm, then v is going to be 200 and e can be n square, which is 4 times of 10 to the power of 4, right? Roads dot length is 3, which is saying that there is an edge from ui to vi with a weight. Okay, weight means the time it takes to reach from ui to vi. Fine. All the ui vi values are from 0 to n-1, which indicates that the labeling of the nodes vertices are from 0 to n-1. So you can go ahead and use an array to implement your adjacency list instead of taking hash map, right? Adjacency list or any kind of requirement can be processed using a n size array, which can be faster on runtime. Now the time values can range from 1 to 10 to the power of 9. You can imagine that you have 10 to the power 4 approximate edges maximum, and if you add 10 to the power 9, 10 to the power 4 times, that means 4 times of 10 to the power 4 times, it will become 4 times of 10 to the power of 13. So this will give you overflow when you check it for 32-bit integer, right? So you have to use a 64-bit integer in this case, and that is why we will be taking all the long integers in our implementation, right? So you always go for 64-bit in this case. UI is not equals to vi. This means that there is no self loop. That means if there is a node UI, there is no edge starting and ending at the same node. That is not happening. There is at most one road connecting any two intersection. This means that if there is an intersection 0 and 1, then there will be exactly one road in between them. There cannot be multiple roads. The meaning of this statement is there are no parallel edges. Then you can reach any intersection from any other intersection. That means you have the graph as one component. There are no more than one component. Okay, so these points are extremely important to actually solve the problem. You have a single component graph. Now let's look at how to count your ways. Now let's assume a graph, and I will call 0 to be the source node and 5 to be the destination node. I am not giving any edge weight, but let's say that if I don't consider the weight factor, then in how many ways can you reach from 0 to 5? Well, it will depend on who are the adjacent nodes of 5. The adjacent nodes of 5 are 0, 3 and 4. So in how many ways can you reach to 3 plus the number of ways you reach to 0 plus the number of ways you reach to 4. If you add all these ways, then you will get the total number of ways to reach to 5. Number of ways to reach to the source node itself will be one way. And here you can reach to 3 in exactly one more way. You can reach to 4 in two ways from the source node by following 0, 1, 2, 4, or you follow 0, 1, 4. These are the two ways, right? So the total ways to reach to 5 will be via 3, via 4 and directly via 0. That is how I have written 4 ways. I think you have clearly understood this, right? Now once you have understood counting ways, let's extend that and include the cost as well. So in our problem, the cost we will be considering is the minimum cost, not just any cost, right? Now my question is, we want to reach from the source node to the destination node, which is 5, and tell me in how many ways can I reach so that the cost will be minimized for the path. So if I know the minimum cost, like what is the minimum cost here? I think it is 6. You just check it out. It will be 6, right? So what are the neighboring nodes of 5? Neighboring nodes of 5 are 3, 0 and 4. So I can only include a neighboring node, I mean an edge to neighboring node, if it is equals to the minimum cost. Like, can I reach from 0 to 5 using minimum cost? Well, it is not possible because the cost is 7 and the minimum cost that it takes from 0 to 5 is 6, which is 0, 3, 5. You can just assume this, right? So 0 to 5 cannot be included. Now if you count the path via 3, then you can take one path. So there is one way to reach to 3, and via 3 you can say that I have one way to reach. Now via 4, how many ways can you reach to 5 with the minimum cost? Now if you see for 4, in how many ways can you reach to 4? You can reach via 1, 2 and then you go to 4. So this cost will be 2 plus 1 plus 1, which will be 4. Total cost is 4 if you follow 0, 1, 2, 4. But if you follow 0, 1, 4, then the total cost is going to be 5, which is 2 plus 3, which is 5. So since these two costs are different, you cannot add them and say 2 ways. You have to just take one way, which is the minimum, right? So the minimum cost is 4 and there is only one way in which you get the minimum cost, right? Now if you add this 4 cost to this 2 cost, is it equals to your min cost? Yes. 6 was the min cost from source to destination. So if it is equal, then you can include this into your ways. That means the count of total ways to reach from source to destination with minimum cost, and that is how you got 2 ways, right? So in this case, we will only be counting the ways for the minimum cost path to any node. If you find a lower cost, then we will be restarting the counting by ignoring the past counted values. Now let's look at another example. If you wanted to reach from the source node U to the destination node V, and let's say the first edge which you saw was direct UV edge. Initially, the cost to reach from U to V will be assumed to be infinity because we do not know the cost. And the count of ways will be considered to be, let's say, 0. Okay, or you can say that the count of ways to reach to U will be 1 because you can always reach to the source node, isn't it? but in how many ways can you reach to destination? That will be 0. Now if you can reach to the destination with a lower cost than whatever cost is mentioned, then you have to restart your counting. So already assumed cost was infinity and you are taking 3 cost, that means it is a lower cost. So update your minimum cost and restart your counting to from 1. Okay, now if you look at the path via t, then the total distance is 3. So is it decreasing your already known minimum cost from u to v? Well, it is not decreasing, but it is equals to the minimum known cost. So what we can do is, this is another way to reach the destination. So I can just increment the counter. Now if you check via w, then the cost will be 1 plus 1, which is 2. It is less than the already known minimum cost. So what we will do, we will be overwriting the minimum cost to 2 and we will be restarting our counting from 1. Why 1? Because the number of ways to reach to w from u is 1, right? That is why it is 1. So I think you are getting the idea how we are counting the ways with the minimum cost. Now based on our previous idea, we will be trying to count the ways by tracking the minimum cost. So here we have 4 nodes and our source node is 0, our destination node is 3. So we will be taking 2 arrays. One will be tracking the minimum cost of each of the node and another one will be counting the number of ways to reach to a node with the minimum cost. So since the source node is 0, the number of ways to reach to the source node will be 1, because we will be starting at the source node all the time. And the minimum cost to reach to the source node will be assumed to be 0. Other costs will be infinity and other ways will be 0 because we do not know how to reach, isn't it? And the constraint already mentioned that the graph is single component and all the nodes will be reachable because this is an undirected graph, right? Now we will be processing each of the edges one by one. Let's say that we process the first edge, which is from 0 to 3. So what is the total cost to reach to 3? It will be cost to reach to 0 from the source node, which is 0, plus the edge weight, which is 3. So it is taking 3 cost. What is the already known cost at 3? It is infinity. That means we are able to improve the cost. So we will be improving the cost. And if we are able to improve the cost, that means the cost plus the edge weight, if it is less than the already known minimum cost, then we will be restarting our counting and we will say that the number of ways to reach to 0 will be the number of ways to reach to 3. Okay, because this edge is actually used to reach to 3 via 0. So it will be 1, which is the number of ways to reach to 0. This concept we have already learned, right? Now let's process the next edge, which is from 0 to 1. So if you calculate the cost, it will be cost to reach to 0 from source node, which is 0, and the edge weight, which is 2. So it is 2. Already known cost at 1 is infinity. So update it to 2 and the number of ways here will be equals to the number of ways to reach to 0, which will be 1, right? Now let's see the next edge, which is 0 to 2. This edge is saying that the cost to reach to 2 will be cost to reach to 0, which is 0, plus the edge weight, which is 1. So it is 1. Cost at 2 is infinity. So update it to 1 and at 2 the number of ways will be the number of ways at the current node, which is 1. Fine, we are done with the processing of 0. Now all these 3 edges have been covered. So let's cover the next edge, which is 1, 3. If you cover this 1, 3, then the cost to reach to 3 will be cost to reach to 1, which is 2, plus the edge weight of 1, 3, which is 1, equals to 3. So the cost at 3 is already 3 and you have found another way to reach to 3. So the total number of ways will now increase by the number of ways you can reach to 1, isn't it? Number of ways you can reach to 1 is 1. So 1 will get added and this becomes 2, right? And this is case number 1, where the cost plus weight is equals to the minimum cost already known at the current node. So in that case, we will be increasing our number of ways. Fine. After this, we will be processing the next edge, which is from 2 to 3. So if you calculate this cost to reach to 3 via 2 from the source node, then the cost to reach to 2 is 1, plus the edge weight to 3 is 1. So the total cost is 2. Now the cost at 3 is actually 3. So update this to 2 since you found a new minimum cost, right? And you restart your counting and update it to a value of the number of ways to reach to 2, which is 1. So here it will be 1. Once you are done processing the entire graph, then the count of ways at the node n-1, which is the destination node, will be telling you the total number of ways to reach from the source to destination with minimum cost, and in this case the answer will be 1. So I think the idea is clear, right? Once the idea is clear, let's now look at an exhaustive dry run using dijkstra min heap with the counting approach, right? So in this case, why we are taking min heap? Because we are trying to minimize the cost, so we will be taking min heap. If we wanted to maximize the cost, we will be taking max heap. So in the min heap, inherently we want the sorting to be done based on cost. So the first parameter of the min heap will be cost, and the second one will be node, because I want to understand at what node we are looking at, isn't it? So this will be the structure of the heap. From the previous explanation, you know that I will be taking min cost and I will be taking countways with the size n, which is number of vertices. Source is always going to be 0. The destination is always going to be the last node. The minimum cost to reach to the source node will be 0. Other cost will be infinity. And similarly, the countways will have the number of ways to reach to the source node as 1 and rest all values to be 0, because I don't know how to reach there, right? We will also be taking a processed array, which will be tracking what all nodes have already been processed from the heap, so that I don't end up processing it again. It is just similar to your visited array, right? Now let me show you how to do the processing. So I will always be starting at the source node, so I will be starting at 0, because 0 will be pushed into the heap. So node will be pushed into the heap with a cost 0, right? Because the cost to reach to the source node is 0, and that's why I will be pushing 0, 0 into the min heap. Fine. I will be processing the min heap until it becomes empty, and I will be taking out the node one by one and start processing. So take out this node 0, 1. The first value is the cost, second value is the node. Once you take out the node, you check if it is already processed. It is not processed, so you mark it as processed now, okay? And try to process all the edges one by one. So we will be going to the adjacency list. Definitely you have to make an adjacency list of this graph, and 4, 6, 1 are adjacent. So let's process them one by one. Now if you see 4, then the cost to reach to 4 via 0 from the source node will be the cost to reach to 0 from the source node, which is 0, 0 plus the edge weight 0, 4, which is 5. So the total cost is 5. What is the cost known at 4? It is infinity. So if we are minimizing the cost, let's update it to 5. As you must have seen in the previous case, that if we are able to get a lower cost, then we will be updating, that means restarting our counting, right? So here as well, we will be restarting our counting. Okay, so what was the node? 4. We will restart the counting and say that if you want to reach to 4, it will be equals to the number of ways to reach to 0, which is the current node. And so I will be writing a 1 here. Okay, I will also be updating the min cost. Once we are done with this, I will also be inserting this node into the heap. What is the cost? Cost will be this 5, right? So 5 will be inserted with a node value of 4 into the heap. Now you see the next edge, which is going to 6. So what is the cost to reach to 6? It will be equals to cost to reach to 0 from the source node, which is 0, plus the edge weight 0, 6, which is 7. Already known cost at 6 is infinity. So let's update it to a lower value 7, and so the count of ways will be updated to 1, which is the number of ways to reach to 0, which is 1. And then we will be pushing the cost 7 and node 6. We are done with this. Now let's look at 0, 1. So if you look at it 0, 1, then the cost to reach to 1 will be cost to reach to 0, which is 0, plus the edge weight 0, 1, which is 2. So it will be 2. The cost at 1 is already infinity, so update it to a lower value, and so the count of ways will be the number of ways to reach to 0, which will be 1. And after that you will be pushing the cost to be 2 and the node will be 1. That is pushed. And now we are done processing 0. Okay, always push the node if it is not processed. Okay, so none of the nodes are processed, and that is why I was able to push 4, 6 and 1. Now once you are done with this, in the next iteration the loop will be taking out 2, 1, because this is the minimum and the node is 1. So node 1 will be getting processed. Now for this node, you first check if 1 is already processed. Not processed, so mark it as processed. Okay, now check the adjacency list of 1. It will have 0, 3 and 2. If you try to process this 0, it will not get processed because it is already processed. So don't do anything with the processed nodes. Now let's look at 3. For this 3, the minimum cost to reach to 3 will be minimum cost to reach to 1, which is 2 here, right? So 2 plus the edge weight 1, 3, which is 3, which will be 5. Already known cost at 3 is infinity. So let's minimize it to 5. And so the number of ways to reach to 3 via 1 by incurring minimum cost will be equals to the number of ways to reach to 1, which is 1 here, right? So you can write a 1 here. Fine. And once you are done with that, you have to insert what is the cost 5 and the node 3. That will be inserted into the heap. Done. Now let's look at this 2. So the cost to reach to 2 via 1, minimum cost to reach to 2 via 1 will be minimum cost to reach to 1, which is 2 plus edge weight 3, which will be 5. Already known cost at 2 is infinity. So let's update this to 5, which we are minimizing. So the number of ways here will be equals to number of ways to reach 1, which will be 1. After this, we will be pushing the entry for 2. So the cost is 5 and the node is 2, and we are done. Now in the next iteration, we will be taking out the next minimum. So there are 3 5 values, but the second value will be checked and 5 comma 2 will be taken out. So once you take out 5 comma 2, we are processing this node 2, right? First check if it is processed. No, then mark it true, already processed. Now you cannot process this 1 even though it is adjacent, because it is already processed, and we can process 5. So the minimum cost to reach to 2 is 5 and the edge weight is 1. So the cost to reach to 5 will be 6. But already known cost is infinity, so I will be updating this to 6. So the number of ways to reach to 5 via 2 through minimum cost will be equals to the number of ways to reach to 2, which will be 1. So update this to 1. After that, we have to insert an entry. So the cost was 6 and the node was 5. And now we are done processing this node 2. After that, our next option will be taken out, which is 5 comma 3, the next minimum, right? So 5 comma 3 is indicating we will be processing this 3. So check out if it is processed. No, not processed. So mark it as processed. And now check all the adjacent nodes. 1 cannot be checked because this is already processed. It will not be processed again. If you look at 5, then the minimum cost to reach to 5 via 3 will be equals to the minimum cost to reach to 3, which is 5, plus the edge weight 3 5, which is 1. So the minimum cost is 6. What is the cost at 5? Cost at 5 is also 6. So if the minimum cost and this cost is same, then you are checking the first condition where the count ways will get added, because this is another way to reach to the same node through the same minimum cost. And so the count of ways at 3 is 1. So 1 will get added here and this becomes 2. Simply, right? And we will not be pushing this node because it is already pushed, isn't it? Now we will check for 3 comma 6. So we can reach to 6 via 3 with the cost of minimum cost to reach to 3 is 5 plus the edge weight is 3, which is 8. Already known cost to reach to 6 is 7. So it is not minimizing. So we will ignore this. And we are done. We are done processing this 3. Now the next thing which will be taken out will be 5 comma 4. This means node 4 is getting processed. So for this node, if we will check if it is already processed. No. So mark it processed. And we will be checking if we can process 0. No, it is not possible. It is already processed. Now we check for 6. We can reach to 6 with the cost of, what is the cost to reach 4? It is 5. And the edge weight 4 6 is 2. So the total cost will be 7. What is the cost at 6? It is already 7. So this means that we are getting the same minimum cost. So our count of ways will increase at 6, and it will be the number of ways to reach to 4, which is 1 plus the already known count. So it will become 2. Okay. And there is nothing else to be added, right? And we are done. Now once we are done with 4, the next option that is taken out is 6 comma 5. That means node 5 is getting processed. Check if it is already processed. No. Mark it as true. Now you cannot process 2, it is already done. 3 is already done. Now for 6, what is the cost to reach from 5 to 6? Minimum cost. Cost to reach 5 is 6 and the edge weight is 1. And this will become 6 plus 1, which is 7. Now the cost at 6 is already 7. So this means you are getting the same minimum cost. So your ways will increase at 6. And that will be equals to the count of ways to reach to 5 will get added. So 2 will get added and this becomes 4. Okay. And there is nothing else to be processed. We are done. Now the next node to be taken out is 7 comma 6. So 6 is the node that we are going to process next. It is not processed. Mark it as processed. Now you check all the other nodes are already processed. So no edge will get processed and arg heap is empty. We are done. Once we are done, the destination is always the last value, and the count ways at n-1 will be giving you the total number of ways to reach from the source node to the destination node by incurring the minimum possible cost. In this case, the answer is going to be 4. So I hope the entire approach is clear. Since we are applying the optimal dijkstra algorithm using the min heap, you already know the dijkstra algorithm optimally takes order of v plus c log v time, and the space complexity will be v plus c. I hope this is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, I will be taking 64-bit integer long, and I will be taking pair, which is long integer pair, and the mod of 10 to the power 9 plus 7. Now, in our main function, we are given the number of vertices and all the edges. So I'll be building an adjacency list using a list of list, and simply add all the bidirectional edges. After doing that, we will be applying the dijkstra algorithm. So let me show you the entire code at one place. So in the dijkstra algorithm, we will be taking a min heap, and we will be pushing the start node with the cost. So start node is 0 and the source is having 0 cost. So cost comma node is pushed. We will be taking a processed array boolean type with all the false values, and we will also initialize count ways of n size with 0, and count ways at the start node will be 1, because it is always possible to reach to the start node with a count 1, right, in one way. Then we will be taking the minimum cost to track for reaching to any node x from the start node, which is the source node. What will be the minimum cost incurred here? It will be min cost at x. Okay, and I will be initializing infinity value, which is long max value in this case. So min cost at 0 will always be 0, because it is always possible to reach to the source node with 0 cost. And after having understood all the initializations, we will be simply running the iteration for the dijkstra algorithm until the heap is empty. So I'll be taking out the top of the heap and then extracting the cost and the current node. So as you remember that cost comma node was how the node was defined for the heap. Now after having extracted the values, we will be checking if the node is already processed. We will continue, we will not process it. Otherwise, we will mark the current node as processed, and I will be looking at the adjacency list. So in the adjacency list, we will be looking at the neighbor node and its edge weight. So if the neighbor is already processed, then we will not be processing. If it is not processed, then I will process it. If the cost to reach to the current node is, let's say it is cost, and the edge weight is weight, then cost plus edge weight, if it is equals to the minimum cost to reach to some node y, if it is equals to the minimum cost to reach y, then we have found another minimum cost path to reach y via x, and in that way we have to add the previously known count of ways to reach y with the number of ways to reach to x. That we already know, right? And we always have to take mod of 10 to the power 9 plus 7. Otherwise, if this cost plus weight is less than the minimum cost to reach to y, already known minimum cost, then we will be overwriting the count of ways to the new ways to reach to x, and our minimum cost value will also be overwritten, and the new node will be pushed into the heap, okay, with the new cost. So after having repeated this for all the nodes present in the heap, we will be returning count ways at n-1, which will be giving us the number of ways to reach to destination from source with the minimum cost incurred. So I think this problem is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.